So today we'll talk about replications. Okay. So first, what is replication? Okay. So replication. Replication means nothing but just copying the data from one location to another location. Okay. That is what we'll call it as replication. It might be within the cluster. Okay, it might be within the cluster. That means in the same cluster, we are copying the data from one volume to another volume, or one vServer volume to another vServer volume. Yeah, we can call that also a replication, or we can do it between the clusters. Okay, between the clusters. For example, I have a cluster called cluster 1, and I'm copying the data from one of the volume in that cluster to another volume in a different cluster. Okay, we can do that. And between clusters in different geographical locations. That means, for example, I have a Netapp cluster in Hyderabad and I have a Netapp cluster in USA. Yeah, I can copy the data from here to there. So that is what we'll call it as a replication. Replication means just copying the data from one location to another location. It might be within the cluster or between the clusters or between the clusters in different geographical locations. Okay. Next. Next thing is migration. Migration means nothing but moving the data from one location to another location. Same thing here also, everything applies like within the cluster or between the clusters or between the clusters which are in different geographical locations. But this time we are moving it. Okay, that is what we'll call it as migration. For example, when we'll migrate the data, for example, I have a cluster which is running on very old controllers. Now I want to replace those controllers with new controllers. Then what I'll do, I'll create a new cluster with the new controllers, and I'll copy the data from my old cluster to new cluster. I'll move the data from my old Netapp controller cluster to new Netapp cluster. Okay, that time we'll call it as a migration. Okay. So even though if it is a replication or migration, what is the end result? We are copying or moving the data, right? So when it comes to replication or migration, generally there are basic types of replications, replication or migration. Okay? Migrations or replications, whatever it is. Okay? So first one is synchronous. Second one is asynchronous. Third one is semi-synchronous. Okay, first one is synchronous, second one is asynchronous, and third one is semi-synchronous. So before talking about these synchronous, asynchronous, or semi-synchronous replications, okay, let's talk about a replication, how it will work, and why we need replication or why we need to migrate the data. Let's talk about the use cases. Okay, when we need to perform these things. So let's assume that I have a Netapp cluster here and I have a server here. Okay, let's assume that this is my server, which is utilizing the space from my Netapp storage cluster. Okay, let's assume this is my cluster 1. This is my server called S1. Okay, and it is utilizing few volumes or LUNs for it, whatever it is. Okay, from the cluster. So on this storage, I have hosted very critical applications. For example, let's assume that this is a bank called ABC Bank, okay, ABC, and whatever I have hosted the data, that is related to a bank called ABC. And here I have hosted very critical applications like internet banking and mobile banking applications. Okay, one is internet banking website I have hosted, and another one is mobile banking. So normally applications and all installed on this server, but the data backend it is stored in the cluster. Okay, so now I have clients, like for example, there is a person who is accessing the data from his laptop, and there is a user who is accessing the internet banking website from his mobile. Okay, from his mobile, like that. So whenever they open the internet banking website, or whenever he opens the mobile banking app from his mobile, what it will do, it will first, the request will go to the server. Okay, and in the back end it will connect to the storage as per the requirement, like a database application. It will connect to the storage and it will pull the data, and based on that it will open the website, banking website, or mobile banking application for the user. Okay, this is how it will work generally. For example, let's assume that this is in um, Hyderabad location. Let's assume that this is in Hyderabad location. Okay. For example, uh, let's assume there is some disaster happened in Hyderabad location. Disaster. Nothing but uh, there is an earthquake or uh, floods due to rains, okay, happened in Hyderabad location. Because of that, I don't have power, or my data center collapsed, or my data center, the water entered into my data center and everything drained, and everything, all the servers, my cluster, everything went down. So if it went down, if my server and cluster, Netapp cluster went down, then whoever the clients, I have hosted my banking applications on this server and cluster, Netapp cluster only, right? So my clients will be not able to access the internet banking and mobile banking applications, right? When my cluster is down. So so what I'll do, after a disaster is completed, I need to bring the server back again, cluster back. I'm not sure if they will work or not. I'm not sure about the data as well. So that is a risk, right? So normally we'll get irritated when you try to access the bank website. You'll get irritated when it is showing like the server not reachable for a second, fraction of seconds, like 10 seconds or 1 minute. What if it will take days to recover the data? What if it takes days to again bring the application back, application and internet banking back? So no one will use your, no one will open an account in your bank, right? Because you don't have a smart services, right? So in order to, and what we need to do in order to avoid these kind of situations, what I'm going to do, okay, I'm going to build another storage in a different geographical location. Okay, I'm going to build another storage in different geographical location, and I'll host another server here as well. Okay, so the storage is pulling the space from this cluster. This is a, let's assume that this is DRS1. Okay, the name is, and this is a DR cluster 1. Okay, so what I'm going to do, I'm going to connect these two clusters with the help of WAN. Okay, with the help of WAN. WAN, just like LAN, we have a WAN as well. WAN means wide area network. This is not a normal LAN. Actually, WAN will be provided by the ISP service providers, internet service providers. We need to purchase a WAN link. Like for example, you need to purchase it from either Reliance, Tata, Airtel in India. In other locations like Verizon, Three Mobile, like that, you need to purchase the WAN link from them, and you need to configure the WAN between the two data centers. For example, I have configured it in Bangalore or Chennai. Chennai, let's assume that. So yeah, these two data centers are connected to each other with the help of WAN. Okay, we don't need to worry about the WAN and all, because this will be, WAN will be taken care by network team. Okay, network team will maintain the WAN, so we are not responsible for that. And this is not only between these two storages. This WAN link is between two data centers. Okay, so you don't need to worry about that. Network team will manage that. Now what I'm going to do, I'm going to create a replication between these volumes from here, from my cluster 1, which is in Hyderabad location, to dr underscore cluster 1. I'm copying the data with via WAN very frequently. Okay, I have created a replication between these three volumes in Hyderabad to these three volumes in Chennai. So whatever the data I have in Hyderabad volumes, the same data I'll be having in Chennai. So whenever any disaster scenario occurred, for example, my as we discussed earlier, my Hyderabad site went down. So my clients so far, they're accessing, this is my production environment. Okay, this is my production environment, which is very critical. And this environment, we'll call it as a DR environment. DR means nothing but disaster recovery environment. Okay, so for example, my Hyderabad site went down. So far my clients are accessing this server, and through this server and this storage, they are accessing the internet banking and mobile banking. So whenever disaster happen, what I'll do, I'll redivert the client access to, okay, I'll redivert my client access to the server in Chennai. Okay, so they'll connect to the server in Chennai. So when my Hyderabad site went down, I have the similar data in Chennai, right? I have configured the similar server, everything in Chennai, a different geographical location. So might be my internet banking and mobile banking will be inaccessible for maybe fraction of seconds, but immediately we'll realize that something wrong happened with Hyderabad location, and we'll switch everything to Chennai. So with the help of Chennai server and Chennai storage, they'll be able to access the internet banking website and mobile banking app, and they can do their work, my end clients. Okay. So whenever my Hyderabad is up and running, what I'll do again, I'll bring my client access back to Hyderabad location. Okay, I'll make sure that all the data is there, and I'll bring everything back to Hyderabad location. Okay, this is the this is how we'll configure disaster recovery, and this is the purpose where we will use, or we will replicate the data from one geographical location to another geographical location. Okay, any questions? So this entire process, we'll call it as disaster recovery. Whenever any disaster happen, still we can recover from the situation by maintaining the same data in the different geographical location. We don't know, right, what will happen. That is the reason. Okay. If you don't have any questions, then we'll start sync, async, and semi-sync. How they will work. A little difference between them. Yeah, we'll talk about those differences. Okay, looks like you guys are good. Now let's talk about the synchronous first. Sync or synchronous. So same scenario. I have a storage here and I have server here. Okay. Not normally multiple servers and multiple storages will be there in every data center. We'll configure replication between them according to our requirement. But here, for example, in order to make it easy for you, I'm just taking one server and one storage example. But in real time, we'll be having multiple servers connected and multiple servers accessing from the storage. So we will not copy everything to DR. We'll copy only critical applications to DR. Okay. Yeah. Let's assume that I have again another storage in DR, another server. Okay. So these two are connected to each other via WAN, data center WAN network. Okay, WAN, wide area network. So this is my cluster one, which is a production one. And this is my DR cluster, which is a disaster recovery site. Okay, now I have implemented a replication between these two servers. Let's assume I have a volume here. Okay, I have another volume here. I have configured a replication between these two volumes. This particular volume is very critical. Okay, I've configured a synchronous replication between these two volumes. Now let's see how synchronous will work. It is not like you can establish a only one replication between clusters. The replication will happen between the volumes. Okay, not between the clusters. So if you have a very critical volume, you can create a synchronous replication between two volume, one for one volume. You have some little non-critical application is there, you can use a asynchronous. Okay, like that you can maintain multiple replications between clusters based on the volume criticality, and you can choose the method. We'll talk about those things a little later. Okay, let's assume that here I have configured a synchronous replication. So in synchronous replication, the data will be continuously copying between source and destination. So this is my source, right? And here is my destination. Okay. So whenever my client copy, first thing is my client will copy the data, right, to the source. Okay, that is the first step. When my client copied the data to the source, okay, what it will do? Immediately, it will copy the data from source to destination. Okay, the data will be copied to the destination as well. Once the data copy to the destination, what destination will do? Destination will send acknowledgement back to the source, ACK, acknowledgement back to the source storage, and then source storage will send acknowledgement back to the server, user, end user, or server. Then only my server can process the next request. My server can copy the next data. Okay, this is how it will work in synchronous. So whenever you copy something to the source storage, immediately the data will be replicated to the destination as well. Okay, After destination receives the data, destination will send acknowledgement to the source storage, and source storage will send acknowledgement to the end server or whatever it is, end user. Then only the next data will be processed. Okay, this is how it will work synchronous. So in synchronous, both source and destination will be having identical data. Okay, both source and destination will be having identical data. No data difference between source and destination. Okay, so we'll call it as RPO. RPO means recovery point object. That means whenever any disaster happen, how much of data we can recover? Can we recover all the data, or there might be a little loss of data on the destination, like that? But here RPO is 0. That means, because why RPO is 0? I mean 100% actually RPO is. That means here whatever the data we are copying here immediately is copying to the destination as well, right? Then only it is my end user is receiving the acknowledgement. So whenever you are copying the data to source, as it is copying immediately to the destination, even if my source went down due to disaster, this whatever the data I have on source, everything will be there in the destination as well. So that is the reason I'm calling it as RPO 0. That means no data loss in the event of disaster if you apply a synchronous replication. Okay, but only thing is there is a distance limitation. The distance between source and destination must be less than 200 kilometers. Okay, the distance between source and destination must be less than 200 kilometers if you want to implement synchronous replication. Why? Because whenever you copy some data, whenever my client is copying some data, immediately it is copying the data to destination, and with once you got the acknowledgement only, it will let my client to copy another data, right? Another set of data. So if my distance between my source and destination is like thousands of kilometers, for example, I have implemented a synchronous replication between Hyderabad and USA. Like the distance between Hyderabad and USA, New York or something, whatever the city in USA, this thousands of kilometers, right? So which will impact the performance. It will take like a minutes of time to copy the data from here to there and get the acknowledgement, which will be impacting the performance of the application, which is not at all recommended. So that is the reason whenever you want to implement the synchronous replication, okay, uh, it is recommended to have a distance between source and destination only 200 kilometers maximum or less than that. Then only you can implement the synchronous replication, or else it is not recommended to implement the synchronous replication. Is it clear?
Clear Annaya.
Cool. Next thing is I'll talk about RTO as well. RTO means recovery time object. Okay, recovery time object. Actually, RPO depends on the replication type, but RTO we cannot say that. Recovery time object means how long it will, how much time it will take to bring the application back. For example, my internet banking site is down, right? How quickly you can redivert the client access to DR and bring the application back to end user. That time we'll call it as RPO. Okay, RPO means how much data you can recover. Like for example, Yeah, here in synchronous, RPO is 0 because whatever data we have on source, everything will be copied to destination immediately. So there is no data loss. But in async and semi-sync, there will be a data loss. So there is a RPO loss. Okay, we'll talk about that. Okay. Okay. Now let's talk about the async. Asynchronous. So in asynchronous, first my client will copy data to the source storage. Okay. Then the data will be copied to the source storage and immediately acknowledgement will be sent to the server or end user. Okay. But the data will be not copied to the destination immediately. Data will be not copied to the destination immediately. When data will be copied, what we'll do, we'll configure a schedule here. Okay. Uh, we'll schedule the replication here. We are not using sync. Async will work based on the schedules. It will not work based on the acknowledgements. Okay. Normally sync will work based on the acknowledgements, but async will not work based on the acknowledgement. It will work based on the schedule. That means here I'll configure a schedule called like 1 hour, every 1 hour something. Okay. That means what it will do, my client, whatever the data copied to the source storage, that will be there. Okay. After that, every 1 hour it will copy the data from source to destination. That means production to disaster recovery based on the schedule. Okay. Based on the schedule. Okay. Let's assume that it copied data at 10 a.m. Okay. After that, again it will copy data at 11 a.m. So meanwhile, whatever the data we have in between 10 a.m. and 11 a.m., that will be there here only. It will be not here. Only once 11 a.m. Uh, schedule triggered, then only it will copy the data, whatever that copy to the source from 11 a.m. to 10 a.m. from source to destination based on the schedule. So that is the reason. Asynchronous will work based on the schedules, not based on the synchronous. Even when it is copying the data from source to destination, my client need not to wait for copying the data because the replication will happen in the background. So my client will be not impacted even it is transferring the data. Okay. So when you compare asynchronous with synchronous, async will give you very good performance. Okay. When it comes to sync there will be a little performance impact. Again, you cannot straight away say that there will be a performance impact, but again it depends on your WAN speed and the distance between source and destination data centers. Yeah, based on that. But when you compare sync with async, sync will be always slow when you compare it with async, because async will not work based on the acknowledgement, and also the data will be not copied to the DR immediately, right? It will be copied to the DR in the backend with help of according to schedule. Okay. Any questions? And when it comes to async, obviously there is a RPO. Again, that depends on your schedule, right? For example, I copied my last time I copied my data at 10 a.m. Okay, sorry, 11 a.m. Now next schedule is like 12 p.m. right? Afternoon, 12. So in the middle, like at 11:25, okay, at 11:25, at 11:25 a.m. My source went down. So whatever the data between 11 and 11:25, that will be not available to you in DR, right? So whatever the data copied to source system for the 25 minutes, that will be not available in DR. will be not able to see the data. My client will be not able to see the data. So that is the RPO. So what is the RPO? 25 minutes of data, whatever the data copied between those 25 minutes. RTO again, it depends on how quickly you bring the services back. That's it. Okay. RTO, it doesn't, I mean, the replication type will not impact RTO. Okay. But here the advantage is distance is unlimited, unlimited distance. That means uh, you can replicate the data from one location to another location. Like there will be no distance limitation when it comes to asynchronous. You can replicate the data from anywhere to anywhere. Okay, no distance limitation. That is the advantage. One is performance, another one is unlimited distance. Disadvantage is there will be a data unavailability uh, based on your schedule. But if your application is very critical, it is not like you need to configure 1 hour only. You can configure it to 5 minutes schedule also. Or if you want, if your WAN is very good, then you can configure 2 minute schedule also. Again, you need to consider a lot of things to use in order to use those close schedules. Okay. Yeah, if you configure your replication for every 5 minutes or 2 minutes, then what is the RPO? 2 minutes only, right? Right? Yeah, maybe less than that. Okay. Any questions on asynchronous? Okay. Now let's talk about semi-sync. So when it comes to semi-synchronous, okay, guys, these synchronous, async, semi-sync, these all are general replications. These are not belongs to Netapp or EMC or HP or Hitachi, anything. Everywhere when you are talking about the replication concept, all these are similar. Like how they will work, everything is similar in all storage vendors. Not only storages, like if you talk about other technologies as well, like for example, in AWS also we'll be having replication from one location to another location. In Azure, all these things will use the similar technology only in the backend. Okay. Only thing is they'll customize the things according to their requirements. That's it. Okay. Yeah. Now let's talk about semi-sync. So semi-sync is a nothing but it is a combination of sync and async. It is neither sync nor async. It is a intermediate component between sync and semi-sync. So let me tell you how it will work. Normally, again, semi-sync also will work based on the acknowledgements only, just like sync, but it will not copy the data immediately. Okay. For example, my client copied the data to source cluster. How long it will allow to copy? Like we need to put that configuration. Like for example, what I keep is 5 seconds. That means my source storage will allow my client to copy the data for 5 seconds. Once 5 seconds period is completed, then it will block my client to copy the data. It will ask my client to stop copying the data. It will block it. And whatever the data that copied in 5 seconds time, it will replicate the data to destination. Okay, it will replicate the data to destination. After copying the data, it will get source destination storage will send acknowledgement to the source, and source storage will send acknowledgement to my client. And again, my client can copy the data for another set of 5 seconds, like that. So it is neither sync nor async. It is using both the technologies, right? But most of the people will not use semi-sync because even it will not give you good performance, and yeah, there is a performance impact as well as there is a RPO as well, right? That is the reason most of the people I have never seen people using semi-sync in a production environment. Either they will use sync or async. That is again based on your application criticality and all. Okay. Any questions? Again, in semi-sync also, the distance is unlimited. And when it comes to RPO, the time is like whatever the timeline you set, like is it a 5 second, 10 second, 15 second, whatever you are setting here, right? That is the RPO. Yeah. The performance is obviously slow in semi-sync as well, just like sync. Okay. Any questions on sync, async, semi-sync? These are very, very important, guys. Like if the interviewer wants to check your basics on replication, then he'll ask you these questions. He'll ask you to explain how they'll work, or he might ask you what is the difference between sync, async, and semi-sync, or he might ask you what is RPO and RTO. Okay, very, very important. Okay, cool. Oh, let's talk about the replication technologies. Okay, replication or whatever it is, migration, both are mostly same. Okay, replication technologies available in Netapp. First one is SnapMirror. Someone unmuted. Do you have any question?
Yes. Are you able to hear me?
Sorry,
Able to hear me?
your voice is not clear.
That is the problem. Okay, sir. I'll just ask the question.
Can you type your question here in the chat? Your voice is not at all clear. Lot of disturbance. Sir, please use earphones or headset when you are joining the meeting. So, yeah. Do you have a question or? Okay. Yeah. So we have different. I mean, we have two types of replication technologies in Netapp. Okay. So one is SnapMirror. Another one is SnapVault. Okay. One is SnapMirror, another one is SnapVault. So SnapMirror is a SnapMirror is a we can use it for DR, okay, disaster recovery. We can use it for replicating the data. We can use it for replication, or we can use it to migrate the data. Okay, we can use the SnapMirror for all these three purposes. We can use it for disaster recovery. We can use it for replicating the data from one location to another location, or moving the data from one location to another location. Okay. So what is the use case of SnapVault? So SnapVault is not a DR. Okay. It is a remote backup solution. That means, okay, backup or archiving solution. Okay. That means by using SnapVault, you can take backup of your critical data from one Netapp cluster to another Netapp cluster. If you lost data on the source Netapp cluster, you can restore it from the destination Netapp cluster. Okay, but you cannot use SnapVault as a DR, or you cannot use. It is not recommended to use SnapVault to replicate the data or migrate the data. It is just for backing up your data. Okay, we'll talk more about that a little later. Okay, just remember these things. Whenever they ask you what is the difference between SnapMirror and the SnapVault, you need to tell them that SnapMirror is a disaster recovery and replication migration solution, which we can use to maintain as a DR or to replicate or migrate the data. But when it comes to SnapVault is just a remote archiving solution, which we can use to back up the data from one Netapp cluster to another Netapp cluster. Okay, that's it. So how we can classify which is snap mirror and which is snap vault. Okay, generally whenever you are configuring snap mirror or snap vault, the command is snap mirror only. Okay, the command is snap mirror only. Earlier in 7 mode we have a different command for snap mirror and snap vault, but from cluster mode itself, if you want to create a snap mirror or if you want to create a snap vault, the same command you need to use. Okay, then how can you differentiate? How can you configure a snap mirror? How can you configure a snap vault? That is based on the policy which you are using. Sorry, first thing is the type you are using, replication type, you are using, and snap mirror policy you are using. Okay, and in Netapp we do have different replication types. Okay, one is DP, DP, LS, TDP. Okay, these are the uh, types, snap mirror types available, not replication. Sorry, snap mirror types available in Netapp. Okay, and snap mirror policies, we do have so many policies like DP default, asynchronous policy, XDP default, mirror and alt, mirror all snapshots. Okay? Mirror latest, like that. Not only that, we have a sync policy. We have a sync policy, like that. We do have so many policies. Along with that, you can create a manual policy as well. That means you can create your own snap mirror policy. Uh, okay, as well. So yeah. So then, as I told you, we can create a snap mirror or snap vault by combining snap mirror type and snap mirror policy. So I'll tell you what all will become snap mirror and what all will become snap vault. For example, if you are mixing DP snap mirror type with DP default, then it will become a standard snap mirror. Okay, it will become a standard snap mirror. And DP snap mirror type can be only used with DP default policy only. Okay, it can be used with only DP default policy. I yeah. Uh, yeah, only DP default policy. Now, I'm mixing XDP snap mirror type with okay DP default or mirror all snapshots or um, mirror latest. Okay, all these snapshot policy types, then it will be version flexible snap mirror. We'll talk about what is standard snap mirror and version flexible snap mirror. I'll tell you the difference later. Okay, version flexible snap mirror. Okay, normally we don't use LS and TS, LS and TDP here. Okay, ignore about them for now. They have a different purpose. We'll use only DP and XDP. Okay, now I want to mix XDP. Okay, XDP with XDP default. Then it will become standard snap world. Now I want to mix my XDP policy, XDP snap mirror type with mirror and world. Then it will become unified replication. Unified replication means on a same source and same destination, we can use it as both snap mirror as well as snap world. We can use the destination volume as snap mirror for DR purpose, replication purpose, or migration purpose, or we can use the same destination volume as a snap world. That means you can recover the data from uh, destination volume to source volume when you lost some data on source volume. Okay, that means both snap mirror and snap world. It will work as a both. Okay, then we are combining XDP with manual policy. Uh, Again, while creating the manual policy, if you mention mirror, type mirror, then it will work as a version flexible snap mirror. If you mention vault while creating the manual policy, it will work as a snap vault. Again, it can be version flexible snap mirror or standard snap vault. Can be. But again, it is based on the policy, how you created the policy. While creating the policy, did you mention mirror or did you mention vault? Based on that, it will. Now, I'm mixing my XDP with sync or strict sync. Then it will become, okay, it will become synchronous snap mirror. Just give me a second, guys. Hello. Yeah. Sorry, guys. Yeah. Based on the combining combination of SnapMirror type and SnapMirror policy, uh, the type of replication will be decided. Is it a SnapMirror, or is it a synchronous SnapMirror, or is it a version flexible or standard SnapMirror, or is it a snap vault, or is it a unified replication? Those things will be decided based on the combination you are using while creating the replication, like SnapMirror type and SnapMirror policy. Uh, Standard SnapMirror and version flexible SnapMirror, these two are asynchronous SnapMirrors only. Okay, only sync. If you use a sync or strict sync policy, then only it will become synchronous SnapMirror. Okay, and this synchronous SnapMirror feature is available from, I think, 9.5. I guess I don't remember, forgetting all these versions when they started it. I think from 9.5 only they have introduced synchronous. Earlier we don't have synchronous snap mirror. Netapp will not support C mode. Netapp C mode will not support synchronous snap mirror. It is only asynchronous. Semi sync is not supported by Netapp. Only sync and semi sync and asynchronous snap mirrors will be supported. Snap mirror or snap vault. Okay. Any questions on snap mirror types? Okay. Now we'll talk about the difference between standard snap mirror and version flexible snap mirror. Normally, standard snap mirror, okay, is like, if you want to create a replication between two Netapp cluster volumes, okay, let's assume this is one Netapp cluster and another Netapp cluster. If you want to create a replication between these two volumes, then the on tap version on destination must be greater than or equal to the on tap version on source. Okay, that means, for example, if my source on tap version is 9 dot for example 1 something, then my destination Netapp cluster on tap version must be either 9.1 or greater than that. Then only standard snap mirror will work, or else it will fail. If, for example, if my destination on tap version is 9.0, then it will not work. Standard snap mirror will not work. Okay, it must be equal to the source version or greater than that. Then only standard snap mirror will work. Don't worry. Anyway, now nobody is using standard snap mirror. Even Netapp removed and they are not recommending to use the standard snap mirror anymore. Now everything is version flexible snap mirror. Okay, version flexible snap mirror. So what is version flexible snap mirror? Nothing. Pretty simple. It doesn't depend on the cluster on tap version. Even if your source is running on tap 9.8 and my destination is running on tap 9.5, no problem. You can create a replication between these two clusters, source and destination. Okay, the condition is eliminated in version flexible snap mirror. The destination on tap must be greater than or equal to source. That condition is eliminated, not there anymore if you are using version flexible snap mirror. Okay, that's it. That is the only difference between standard and version flexible snap mirror. Any questions? And one more thing, uh, earlier in 7 mode, we can create snap mirror at volume level and Q-tree level. But when it comes to cluster mode, okay, you can create replication only at volume level. Okay, no Q-tree level, no LUN level, nothing. Only on volume level you can create a snap mirror. Sorry, volume level as well as SVM level. They have introduced SVM level snap mirror as well, SVMDR. Okay, yeah, that's it. Okay, let's stop it for today because so much of theory. Just go through the video. We'll start snap mirror practically from tomorrow. I'll show you how to create and what are the steps involved to create a snap mirror tomorrow. Okay. Let's have a class tomorrow as well because I'll be taking off again on Monday. So let's cover it tomorrow. If you are, if you can make it, let's have a class on Sunday as well. I'll not skip it this time. Yeah, it's up to you. Let me know. But tomorrow, let's have a class. Join the class. Sunday is optional based on you. Okay. Thank you guys. Have a nice day.